What are superconductors, and how do they levitate objects? Imagine a world where objects float effortlessly in midair without any strings or wires holding them up. This is not magic but a fascinating science phenomenon involving superconductors. Superconductors are special materials that, when cooled to very low temperatures, can carry electricity without losing any energy. This means electric current can flow through them forever without any resistance. Normally, materials resist electrical flow, turning some energy into heat, but superconductors do not do this once they reach their critical temperature. The critical temperature is the specific low temperature at which a material becomes superconducting. For most materials, this temperature is extremely cold, close to absolute zero, which is minus 273.15 degrees Celsius. However, some materials called high-temperature superconductors can become superconducting at higher temperatures, like minus 196 degrees Celsius, which makes cooling easier with liquids like nitrogen. Superconductors also have a unique behavior called the Meissner effect. When a material becomes superconducting, it pushes out magnetic fields from inside it. This means magnetic forces are expelled from the superconductor, creating a magnetic field that opposes external magnetic fields. This is different from regular magnetic materials, which can attract or attract magnetic objects. Because of this magnetic expulsion, superconductors can make magnets float or levitate above them. This is called diamagnetic levitation. When you place a magnet above a cooled superconductor, the superconductor's magnetic field pushes back so strongly that the magnet appears to float in midair. The superconductor creates tiny electric currents on its surface that generate a magnetic field opposing the magnet's field. This pushback force is what keeps the magnet floating without touching anything. Superconductors need to be kept very cold to work properly, which is a challenge for everyday use. But they are used in many important ways. For example, in magnetic resonance imaging machines, superconducting magnets produce powerful magnetic fields. High-speed trains called Maglev trains float above tracks using superconductors, reducing friction and allowing faster travel. Power companies also use superconductors to transmit electricity more efficiently over long distances, saving energy. For students studying physics, understanding superconductors involves knowing that they have zero electrical resistance, become superconducting below a certain temperature, and can repel magnetic fields strongly enough to make objects float. Visualizing magnetic interactions and remembering the importance of cooling can help make this topic clearer. Breaking down these ideas into smaller parts and using diagrams can make learning about superconductors more fun and easier to grasp.